All right, Integrated Math 3 students, we had some people asking about this last topic, the mixed multi-step factoring with an equation. So this one has a lot of steps to it, and if you're finishing it in 30 seconds, that is a sign that you are not doing this authentically, okay? So let's follow along with these steps here, and we'll try to make sure that it's explained properly to you. So whenever I'm looking at these questions, the first thing I always want to do is try to look for a GCF. Okay, I want to look for a GCF. So I look at all three of these terms here, and there's no number that I can factor out. I noticed that the front term has a negative, so I'm probably going to want to get rid of that. I'm going to go ahead and for this one, I'm going to say, I'm going to put a negative. I'm going to say, okay, I need to factor that out. Then we look at the variables. What's the most number of x's that I could actually take out of this? This one has 5, 4, and 3. I can't take 5 because they, at most, I couldn't take 5 from this third one because the most I could take was 3. So we're going to say negative x cubed is going to be our GCF for this one, okay? That's what we want to factor out. So we go ahead and rewrite this. We're going to put that x cubed on the outside, and then we have these 3 terms in here that we need to factor out that GCF. So the first term becomes x squared. I'm dividing it from that term, right? I'm dividing the negative x cubed, which I forgot my negative here, so let's put that up there. My negative x cubed is divided from that right there. So that one's done. Now we want to do the next one. I'm dividing a negative from this 4x to the 4th. So that gets me negative 4x. So that one's done. And then I'm going to divide negative x cubed from negative 4x cubed. So that gets me positive 4. So now I have that. So, and that's equal to 0. So now the next step, that's just GCF. So the next step is to use other factoring methods. So this is called mixed multi-step factoring because you're going to have to use all the factoring tools in your toolkit. So is this factoring by grouping? Is it difference of squares? Is it factoring a quadratic? So we look at what we have here, and I'm going to look in this parentheses, and I see that, and it looks like a quadratic to me. It doesn't look like difference of squares because it has 3 terms, but I'm pretty sure I can factor that. So that means I'm going to do this. So we write down here, negative x cubed. I think I can break that apart factoring a quadratic. So I have my 2 binomials. So I take this 4 here, and I need to break it apart. What do I multiply to get this 4 that adds to get this negative 4? So I'm going to write that over here. 4 breaks into 1 and 4, 2 and 2. Well, which ones add to get the negative 4? Well, 2 and 2 add to 4, but if I make them both negative, it still satisfies that they have to multiply to get this, but also add to get that. So it's x minus 2 equals 0. So now we're almost done with this problem, actually. We just have to set all of these equal to 0. So we have our 3 solutions that are going to come up from this. It is a cubic. It does have a multiplicity, so we've talked about that. It's x to the 3rd. That means there's a multiplicity at that point, but that's not going to affect our answer. We still have 3 values. So the power is 5, so we should have 5 solutions, but one of them counts 3 times. What do I get from this one? Well, remember the rule is you set it equal to 0, but on these they're pretty easy. You can just flip the sign and we get positive 2 and then positive 2. This one kind of has a multiplicity as well. Here, this one that's by itself, if I set negative x cubed equal to 0, I'll get rid of the negative by multiplying by negative 1. And then to get rid of that, I do a cube root. But it doesn't really matter because x, when it's by itself, is always going to equal 0. So we're going to go ahead and start by typing that in. Let's give that a try. And then we're going to do one more example in this video. So this is 0, 1, negative 2. No, it was positive 2. And I'm curious if it's going to let me do positive 2 or if it just wants 1. Hopefully it'll let me do that. So let's submit that. Okay, I got it right. And you'll see it's a little forgiving. Like it would have if you had just put it once, because there's 2 of them that are positive 2s, and you can't even see that down here. So positive 2, both of those. that would have that would have been annoying, kind of, if I had written it twice and it only counted it if I had written it just one time. So that's good. Let's do another one. This one's definitely more interesting, a little more difficult. We'll see what kind of factoring we get into here. Right away, again, the first step, you're looking for a GCF. So let's go ahead and write GCF. Try to figure out what that is. I noticed that there's a negative up here. And right away, that tells me that I want to get rid of it. So I'm going to put a negative in there. Next, I look at the numbers. I got 4, 14, 16, and 56. What's the greatest number that I can divide from all of those? Well, when I look at it, I'm thinking, I want to say 4, but you'll notice that 4 doesn't go into 14, so that won't work. So then I'm sort of left thinking, okay, well, it's probably 2 then. So I'm going to go with 2. All right. So we're going to do that GCF. So we're going to rewrite this. So this is a lot of work here. So this should not be just one problem that takes you, 30 seconds to do. However, my GCF's not done. It's not just 2. I acted like I was ready. We have x's in here, and we can factor some of those out. What's the most amount of x's that I can take? Well, that would be x squared. Okay, so I can take that from all this. So I'm going to write that up, negative 2x squared. And then we're going to rewrite this GCF in here. So divide negative 2x squared from this one. That's going to get me 2x to the third. Probably need more space. I'm going to erase that. Negative 2x to the third. Then I divide this one by negative 2x squared. So I get, that is going to turn into a negative. Positive divided by negative is a negative. 7x squared. Then we keep going. Positive 16x cubed divided by negative 2x squared is going to be negative 8x. And then we do this last one, negative 56x squared. The x's are going to go away. They're going to divide out. And we need 56 divided by negative 56 divided by negative 2. If you don't know that, I mean, I think I could do it without a calculator, but I'm just going to do that. So it's 28. So this is positive. This is actually going to be positive because negative divided by negative is positive 28. So there we go. We've factored that. Now, step 2 is look for other factoring methods that you can use. Well, since I have 4 terms, there's only one factoring method that can deal with that, and that is factoring by grouping. So we're going to go and do that. I'm going to group these up like so. So you have to remember your factoring by grouping techniques. So that's what makes this so challenging, is you got to remember those techniques. We're going to rewrite this down here. By the way, this is equal to 0. So this is going to be negative 2x squared. Now, I'm looking in the first set of red. I'm doing another GCF. What's the GCF of this first one? Well, that is x squared is what I'm going to factor out. So x squared. What that leaves inside is 2x minus 7. Okay? I'm going to underline that red right there. Okay? Next, and this is kind of getting dizzying how much is actually happening. So try to follow along. Next, we take the negative 8x plus 28, and we're dividing out something. We know it won't be an x, but looking at it, it looks like I need to get rid of this negative up here. So I want to factor that out so that it can match. 4 will go into both of these. So let's try negative 4. Get rid of that. And what does that leave in here? Well, it's going to be 2x. When I factor out the negative from this, it's going to be minus 7. That's a good thing, because we notice that we have this common binomial. So if you have your notes, you're looking at your steps for factoring by grouping. We needed this common binomial here. So we're going to go ahead and do the next step, which is this. This is going to be lengthy. This is as complicated as factoring will ever get, I promise. So now, we have to factor out that common binomial, the red. This is all just staying up here in the front, by the way. We're just going to leave that there. So I'm going to rewrite this inside. It's 2x minus 7 times x squared minus 4. And at this point, I can actually get rid of this. And what let me color coordinate this so that you see what happened. The red became one binomial. I'm going to underline this blue, and this is green. They took up those positions right there. Okay, so we factored out our common binomial, and it completely changed things. All right, now we have to continue. We have to look, can I do any other method of factoring to this? So up here I'm going to put factor by grouping, because that's what we did. Then right here, what is there any factoring that I can do to anything that's left here? Well, not the red, but I can actually factor the blue green right there. So this is actually a difference of squares. So this is what we end up doing on for this first one. By the way, this is all equal to 0. Make sure I keep that up. So it's negative 2x squared, 2x minus 7, and then this second, the blue-green term is going to break into two other terms. X minus 4, so we square root those. Oh, not the negative 4 though. We just want the 4. So this gets us x on the fronts of these, and then we have, what's the square root of 4? Well, it's 2. So we want plus 2 and minus 2. That's just the factoring. So we have factored this. Look at how much we've changed. We call this, again, this is polynomial gymnastics. We have completely taken the original problem and manipulated its form into an utterly different shape. And you used the different tools. We used the different tools at our disposal to do that. So it's just knowing how to use those moves in the right places, okay? So looking at this, we have 1, 2, 3, 4 solutions that we're going to get. So I'm going to go ahead and write those out, and this is what's going to go inside of Delta Math. So I think this is as complicated as a question will be on here. So this first one, we talked about that a moment ago. Whenever the x squared, whatever it is by itself, it's not in parentheses, it's going to be a 0, okay? Let's go ahead and do the easier ones, which will be x plus 2. We change that sign, it'll be minus 2. And then let's do the last one here. X minus 2 will end up being plus 2. Then let's look at this one right here. Okay. I need to set that equal to 0 and solve for it, because it's not going to be positive 7. This is actually going to be a fraction whenever you see this. So this is 2x equals 7 because I add 7 to both sides. And then we're going to divide by 2. This goes away, I get x equals 7 halves. So that's going to be what our answer is. And we have all 3 of these answers here, or 4 of them, and that's what we're going to type into Delta Math. Okay, so let's do that. 0 is one of them. Then we add another. We want 7 divided by 2. We add another, negative 2 and 2. And we submit this, we'll see. Okay, we got it right. And then look at the complicated steps. They show exactly what we did on here. All of this work is exactly what they show. Okay, and they go through this. Factor out the GCF. Factor by grouping is what we established from this. Factor out the binomial. The binomial is this one here. Difference of perfect squares. So we had difference of perfect squares here, and we did that. Set each factor equal to 0, solve for x. So it's very clean in its steps. I really like how Delta Math is showing these steps on here for you guys. So if you get stuck on certain problems, make sure that you look at those, the solution path, and try to fix your mistakes, because that's what this is all about, is just learning. The only way that you can do better at this is by practicing. It's okay to make the mistakes. Hopefully this is a helpful video. I know I only did 2 problems, but at least we're talking through the process and the thought processes of factoring.